The reactant has two alcohol groups. Now it is treated with one equivalent of acetic acid. This compound name is acetic acid. And we know that when alcohol treated with the acid, the basic reaction is carboxylic acid. When treated with the alcohol in the presence of H plus, so the general reaction is lone pair attack, leaving group will leave, and corresponding carboxylic ester will form. And we know that rate of esterification indirectly proportional to steric factor of alcohol and also indirectly proportional to steric factor of carboxylic acid. In case of benzylic carboxylic acid directly proportional to positive charge on the carbon, like these kind of compounds if they are present. So here if you observe, it is primary carbon, it is tertiary carbon. So this is less sterically crowded, and it is more sterically crowded. That's why this nucleophile attack on the carbonyl carbon, leaving group will leave based on this point. Therefore, the corresponding product is tertiary alcohol, it is not participated, primary alcohol participated, and corresponding ester is formed. Carboxylic ester is formed. Now it is treated with benzoic anhydride. It is a benzoic anhydride. Again, if you see the benzoic anhydride, it is a leaving group. So benzoic anhydride, it is a leaving group. So definitely our reactant should behave like nucleophile, because here leaving group is present, RCO leaving group. So we should look for the nucleophile, and here it is a nucleophile and it is also nucleophile. But because of resonance, it is a weak nucleophile and it is a strong nucleophile. That's why lone pair attack on this carbon, leaving group will leave, and finally the corresponding product is O C double bond O PH O C double bond O CH3. So this reaction is called as, it is also esterification and esterification, also known as Fischer esterification. This is our final product. The alcohol treated with SOCl2, but this alcohol is allylic alcohol, alpha, beta, gamma. When this kind of alcohol is present, when alcohol treated with SOCl2, SNI and SNI dash both are possible. SNI and SNI dash. First I will write SNI. In place of OH we should write Cl. So this is the SNI product. To write SNI dash directly, we should shift the double bond here and write corresponding product like this: alpha, beta, gamma. Alpha, beta, gamma. So here the chlorine attached to the gamma carbon, that's why it is a SNI dash. Among SNI and SNI dash, SNI dash is major. Among SNI and SNI dash, SNI dash is major. Now these two compounds treated with moist Ag2O. So moist Ag2O means AgOH. So if I see the general reaction, alkyl chloride treated with Ag plus, it forms R plus by losing the Cl in the form of AgCl, and it will react with the corresponding nucleophile OH minus and forms alcohol. So this is a general reaction. Similarly, in this case also, if the first compound loses leaving group, it forms C plus. Second molecule loses leaving group, forms corresponding C plus. Now these two are resonance structures. Now these two react with the OH minus and corresponding product formed. And it is our corresponding final products. And among these two, it is a stable alkene. Among these two, it is a stable alkene. Therefore, it is major. Therefore, it is major. In this case, both are giving the same carbocation because of resonance. And finally, you are getting two products. Among these two, we are considering stable alkene as major product. The secondary alcohol treated with NaBr and H2SO4. So when alcohol treated with NaBr in the presence of H plus, primary SN2 are no reaction. Secondary and tertiary alcohol prefers SN1 reaction. Secondary and tertiary alcohol prefers SN1 reaction. Since it is a secondary alcohol, so it loses first H2O in the presence of H plus. After that, migration takes place. Now this migrated carbocation reacts with the OH minus and corresponding product will be formed like this. So this is like SN1 mechanism. In the presence of H plus, secondary alcohol forming the carbocation, and carbocation undergo migration, and finally it is giving the corresponding substituted product with the OH minus. So this entire mechanism is SN1. Now this alcohol treated with CH3O minus, Na plus and CH3OH. And here CH3O minus is strong base and less bulky base. Strong base and less bulky base. And the reactant not supporting even CB mechanism because beta position, it is a alpha position, it is a beta position, So here at beta position there is no minus R group, therefore E1 CB not possible, only E2 possible, and here of course not OH minus, here Br minus, so Br minus attached, it is a Br, please correct it, Br. So alkyl bromide treated with the CH3O minus, this reaction is Williamson's reaction. In the Williamson, we are expecting, because of strong basic nature, we expect SN2 and E2, and we know that one of the reactant is tertiary, therefore E2 is major. So SN2 product looks like this. It is a SN2 product. Next, E2 type elimination. So these are the products from the elimination. E2 mechanism. Now here SN2 and E2, because of tertiary carbon in Williamson ether synthesis, because of tertiary carbon, elimination is major. Now among these two products, because of less bulky base, stable alkene is major. Okay. Now the reactant has two pi bonds, two alkenes. Now it is treated with the Bayer's reagent called alkaline KMnO4. It is a Bayer's reagent and it follow syn hydroxylation. Therefore, because of syn hydroxylation, less sterically hindered alkene will be oxidized, and we get corresponding vicinal diol and corresponding glycols, and this reaction is known as syn hydroxylation example. This reaction is an example of syn hydroxylation. Now it is treated with oxalic acid. Now it is treated with oxalic acid in the presence of H+. So immediately we should think like it is an alcohol and it is an acid. When acid plus alcohol both are present, we expect esterification. So in esterification, what happens? Nucleophile attack, leaving group will leave. Nucleophile attack, leaving group will leave. And finally the corresponding properties C double bond O, C double bond O, and corresponding ester. So this is our final product. So ఇక్కడ మనకి కార్బాక్సిలిక్ ఎస్టర్ ఫామ్ అయింది, ఇక్కడ మనకి కార్బాక్సిలిక్ ఎస్టర్ ఫామ్ అయింది. So because of these arrow marks you can understand. So this reaction is known as esterification. Secondary alcohol treated with K. K means potassium. Like sodium, we are taking potassium. Potassium and alcohol has acidic proton with respect to metal, therefore loses proton in the form of O- and K+ and loses H2. Now here the interesting point is it is a chiral center above the plane and it is also chiral center above the plane only. So both are above the plane. That's why it is a retention in configuration. That is retention. Now it is treated with CH3OTS and it is alpha carbon. There is no beta proton, we are having only alpha proton. Now here it is a good leaving group, therefore O- attack at this carbon, leaving group will leave through SN2 reaction, and this reaction is known as Williamson ether synthesis. Williamson ether synthesis. Therefore the corresponding product is above the plane OCH3. Therefore overall reaction also retention in configuration. Chiral center above the plane, chiral center above the plane, chiral center above the plane. So with respect to that leaving group and the nucleophile positions, it follows retention in configuration. Secondary alcohol. It is a secondary alcohol treated with TSCl. So TSCl means tosyl chloride. So simply here what happens? Lone pair attack on the tosyl group, leaving group will leave, and finally we get corresponding OTS and HCl, H+ and Cl-. So to remove this HCl, we are adding pyridine. So pyridine remove the HCl in the form of salt, pyridinium chloride. సో మనం ఇక్కడ బేస్ ఎందుకు యాడ్ చేస్తామంటే హెచ్సిఎల్ని రిమూవ్ చేయడం కోసం. హెచ్సిఎల్ని రిమూవ్ చేస్తే ద రియాక్షన్ విల్ ప్రోగ్రెస్ ఇన్ ద ఫార్వర్డ్ డైరెక్షన్. నౌ ఇఫ్ ఐ ఫోకస్ ఆన్ ది chiral center, the stereo not changed, below the plane OH, below the plane OTS. Therefore it is retention in configuration. So chiral center stereochemistry not changing. Now it is treated with CH3COO- Na+, sodium acetate. It is called sodium acetate. And sodium acetate is strong nucleophile and OTS is good leaving group. And strong nucleophile, we expect SN2 type of reaction. Therefore here strong nucleophile CH3COO- attack from the above the plane, leaving group will leave. Therefore the final compound is methyl is above the plane and here OTS is below the plane. Therefore nucleophile OCOCH3 above the plane. OCOCH3 above the plane. So it is our final product. The reactant has two alcohol groups. The reactant has two alcohol groups. And the difference is one is less sterically crowded, another one is more sterically crowded. Now it is reacting with benzoyl chloride. Benzoyl chloride. Therefore, we expect two types of reactions. O lone pair can attack and O lone pair can attack. When it is the case, RCO leaving group reacting with two different alcohols, and here less steric factor, more reactive. Less steric factor, more reactive. Therefore, we have to consider this SN2 and we should not consider this SN2. And the corresponding product is above the plane, below the plane, OCOPH. Sorry, less sterically hindered, this one. Therefore, below the plane, OCOPH. Now it is treated with copper 300 degrees Celsius. So it is a carboxylic ester with copper, there is no business. But here it is a secondary alcohol and copper. So this is oxidation. Secondary alcohol with copper, oxidation. Therefore, secondary alcohol undergo oxidation and finally gives corresponding ketone and here ester group. It is our final product. So for oxidation of secondary alcohol, we can use copper, PCC, PDC, opener oxidation, Jones reagent, and CrO3 anhydrous medium. So we can use any one of these reagents to oxidize secondary alcohol to ketone. Now in this process, ester should not be affected. Alkene treated with bromine water. So when alkene treated with the bromine water, alkene react with the Br plus, leaving group will leave. So bromine form 3-membered ring. Now it react with the most available nucleophile at tertiary carbon. Finally, it gives corresponding product like this. So this overall reaction is anti-addition. Now here with respect to stereo, if I talk, Br 3-membered ring and a nucleophile above the plane. Suppose 3-membered ring is formed above the plane and below the plane OH. So this is a reaction with the bromine water. Now it is treated with the AgNO3. So AgNO3 remove the Br minus completely. And form corresponding stable carbocation. Now here we expect migration because this carbocation is more stable. So after migration, both molecules are converting like this. So both loses the Br minus, and then here hydride transfer takes place. Finally, it forms corresponding stable C plus, and here lone pair resonance possible. And the corresponding product is double bond OH plus. Now it loses a proton and corresponding ketone will be formed. Corresponding ketone will be formed. So it is our final product. When alkene treated with the Bayer's reagent, cold alkaline KMnO4, it is also known as Bayer's reagent, and this reaction is syn hydroxylation. Syn hydroxylation. Therefore, here two products are possible: OH below the plane, OH below the plane, OH above the plane, OH above the plane. It is a syn hydroxylation. Now it is treated with PCC. You can use PDC. You can use copper. You can use CrO3 anhydrous medium. CrO3 anhydrous medium. So like this we can use opener oxidation, Fenton's reagent. We can also use NBS. We can also use X2 plus OH minus, X2 plus CO3 minus 2, X minus plus XO3 minus. We can use any one of these reagent. So here what happens, secondary alcohol undergo oxidation, tertiary alcohol will not be affected. Therefore the corresponding product is ketone, OH above the plane, methyl below the plane, plus another compound, ketone, OH below the plane and methyl above the plane. So when this undergo oxidation, it forms corresponding oxidized product. When this compound undergo oxidation, corresponding product undergo oxidation. Epoxide treated with sodium azide, NaN3. It is a sodium azide. Now here N3 minus is strong nucleophile, and strong nucleophile epoxide primary greater than secondary greater than tertiary. Now the reactant, it is a secondary carbon, it is a tertiary carbon. So strong nucleophile attack at secondary carbon, ring opening takes place. Now the corresponding product is O minus and N3, and I am considering acidification granted because nothing is mentioned. Therefore corresponding tertiary alcohol and azide. Now it is treated with the H2PD, and H2PD is reducing agent. And here the reducible functional group is alcohol cannot be reduced, but N3, RN3 can be reduced to RNH2. RN3 can be reduced to RNH2. Therefore here the corresponding product is tertiary alcohol, and N3 is converted to NH2. N3 is converted to NH2. So it is a catalytic hydrogenation. Epoxide treated with the ammonia, and which is a strong nucleophile. Therefore when strong nucleophile react with the epoxide, we have to follow primary, secondary, tertiary. Therefore it is a secondary carbon, it is a tertiary carbon. N lone pair attack at secondary carbon, ring opening takes place. Now it is treated with the HNO2. And we know that the basic reaction is when RNH2 treated with the HNO2, it is a aliphatic primary amine. So we have to write down in place of NH2, we should write N2 plus. We have to remove the N2 plus and write down the C plus. So similarly here also we can expect by losing NH2, it forms initially N2 plus. Now it loses the leaving group N2 gas and form carbocation. Now here two possibilities we can expect because stereo is not mentioned clearly. One is, suppose methyl is migrated. Methyl migration takes place. So it is our corresponding product. So this methyl group is migrated here. Now here lone pair resonance possible, and after removal of proton, corresponding product is ketone like this. Another possibility is, if you observe clearly, another possibility is ring contraction. Another possibility is ring contraction. Even at that time also, corresponding octet is possible. Now because of lone pair, it loses proton and finally it gives corresponding product cyclopentane and double bond OH plus. Now it loses a proton and gives corresponding ketone. So here stereo is not mentioned of the reactant. Therefore 6-membered ring ketone and 5-membered ring ketone both are possible. Now among these two, we know that 6-membered ring is more stable. Therefore it is a major product. 6-membered ring is more stable. That's why it is a major product.